Okay, so I will start my today's another coding practice. So this is the question. So you were given an integer array nums and two positive integers m and k. Okay, return the maximum sum out of all almost unique subarrays of ranks k of nums. Ranks k subarray, unique subarrays of ranks k returns maximum sum. I see. Maximum sum all maximum sum of all almost unique subarrays. I see. Okay. If no such subarray exists, return 0. Okay. A subarray of nums is almost unique if it contains at most m-digit elements. I see. If it has at least m distinct element, the subarray is called almost unique. And in this question, I will think of ranks k, unique, almost unique subarrays, and I will return the maximum sum of them. Okay, I see. So in this question, let me quickly write the interface first. So in this question, the date input should be so array nums m and k, and I will return the maximum sum of almost unique subarrays. Let me call it almost AUS subarrays. Okay. And I will return so nums array. Okay, let me do the quick check on the constraint of the argument. I mean, yeah, let me confirm the data input. So nums is the integer array. Okay, and if the range of nums is 0, obviously there isn't any subarray, so I will return 0. Okay, and m. So m is the number of distinct elements needed in AUS. Okay. And k is the max length of subarray to be solved. Okay. See. If m is 0, at least 0 distinct element should be in the subarray. So every subarray meet this condition. So I will return maximum sum of all the possible subarrays. Okay. And if k is 0, ranks of subarray is 0, so can I? Yeah, I will. If k is 0, I will return 0. Okay. Yeah. Okay, good. So I confirm this. So let me think with some examples. So if nums is say 1, 2, 3, 6, 5, 3, 5, 2, 7. And m and k. So say m is 2 and k is 3. So in this case, I need at least, okay, in this case, I will take a look at every subarray whose rank is 3. So this is possible, and this is also possible. Yeah. Actually, this is limited. Yeah. and I have to confirm distinct element. Distinct element is now, this is 3, and this thing is 2. Oh, this isn't so interesting. So let me think this. So in this way, distinct subarray is now only 1. Oh, so sorry, I mean, now currently I'm writing distinct element numbers. Yeah. Okay. I see. So yeah. And here, this is still distinct 1. And let me move forward. And now I have 2. And if I move it again, it should 3. So in this case, because M is now 2, okay. So I should return 1, 2, 3, 4. So yeah, okay. So basically, when we think of the algorithm, one approach I've come up with is I take every window possible. Probably there should be a length of the array minus k arrays, and then I will take a look at the I'll count the number of element, distinct number of element, and if it is larger than k, I will update the global, current max sum. Yeah. So in this way, it would take n squared time, assuming that n is the ranks of these nums. Yeah. Basically, and because in each subarray, I need a counter, which counts the element. So probably should be the ranks of, k, because if each element is different, the counter should have k element, k key value pairs. So yeah, it should be all k. So, so another approach I can use is kind of writing window. So as I said, I need counter. Yeah, and basically my approach is for each num, I will update counter and also some, yeah, window sum. So, yeah. And if it is a OUS, update max sum. Yeah. Okay, in this way, I just have to take care of the, so I mean, as long as I have the current state of the subarray, I mean window, if I move the window, I can updates the counter by just adding one element and also removing element which was popped out. Then, yeah, after that, I can take a look at the, number of keys in the counter to know the distinct number of characters. So it's okay. And also for some window, yeah, it is also found in the constant time, because if I move the window, I just have to add the number which is appended as a tail and also remove the, subtract the element which is popped out as a head. Okay. So that's the thing. So let me work on the implementation. Oh, so in this way, the time complexity should be n, because firstly I will make the window length k, and then I have to move the window n minus k times. And for each moving operation, it takes only the constant time, as I explained. So the time complexity should be O of n. And also for space complexity, yeah, the same as the brute force approach, because I need the counter. That's the only data structure which takes non-constant space. Okay. So if I take a look at this, so yeah, I think this is a good example, because as I move through the window of length k, firstly, the number unit count is decremented to 1 when it reaches 333, and then if moves forward, keep moving forward, the number of unique elements is increases until 3. So yeah, I think this is a good example. So in this way, I should return. Oh, no, maximum sum out of all of them. No, almost. Okay, sorry. So if this is 2, so 1, 2, 3 is okay, 2, 3, 3 is okay, 3, 3, 3 is not okay. So 3, 3, 2 is okay, 3, 2, 1 is okay, so it should be 4. Okay, good. So I will do the implementation. So first 3 max I will initiate it with 0, because if I can't find subarray or you almost unique subarray, I should return 0. So I write to begin with 0. So first state of the window is this. Window range. Yeah. And then at this moment, so counter, so num count the hash map, and one more thing is current sum is 0, and I will, yeah, reverse it. So I wrap these times. Okay, one thing I have to take care is I I will take care of the index size of the range, because if k is much, I mean k is larger than the ranks of this array, I have to take care of that. Yeah, so I'm reminiscing of it later. Okay, so in this way, I create this initial state of the window statistics as number to count and count array. So now I remove the right pointer. So okay. I will move the right pointer. So, but before that, I have to pop out the element which was at the original left. So this is the out element. To count out also. Yes, and one thing I have to do here is, because if the num to count out, this becomes 0, I should delete this key from num to count. Yeah. Because I will take a look at number of keys to know if the subarray, I mean, to know the number of subarray distinct number of elements. Okay. So here it moves the left pointer. So then okay. Then oh, is I will define the helper method. So if it's almost an encounter, if subarray of strength k, and at least empty. Okay. So I will update max sum. Yeah. Then I will return max sum in the end. And one thing I forgot to do is in line 49, after initiating the first state, I have to do the same thing. Yeah. Okay. Oh, and I forgot to move right pointer. Okay. Yeah. So let me quickly check. So as I said, I will initiate max sum with 0 in line 51. And in line 53 to 61, I initiate the first window with blank state. Yeah. And yeah. So I initiate num to count and max sum. Ah, I see. Sorry. It was okay with current sum. Yeah. Okay. And for in line 57, I will take a look at this number and I will add it to the num to count and also current sum. And I will check if this is almost unique subarray in line 61. And if it is true, I will update max sum. Okay. And in line 63 to 76, I will move the left and right pointer one by one. And in line 64 to 68, I firstly pop out the number from which was at the left edge, and I represent them to count and also current sum and move the left. Then in line 20, I first remove the right, and then I represent them to count and current sum. Then in line 35, I will check it, and if it meets the condition, I will update max sum with current sum, and I will return max sum. Okay, so as I said in line 54, I will quickly do the case when, yeah, when the when the k is larger than length nums. In this case, I should return 0. So I can add and return it. Yeah. Okay. And also, as I've written, if k is 0, so if k is 0, length of the nums is 0, so it breaks at line 57. So I will use it as also the edge case. Oh, probably I need the escape result. Sorry. So I've already handled it. So length num is smaller than k. Yeah. K minus 1 is larger than length num minus 1. Yeah. Oh, so if k minus 1 is larger than length num minus 1, Okay, it returns 0 already. Okay, good. Okay, I'm pretty sure that this works. Let me run this code. Or maybe I should work through this code with, say, very small case. Say. Let me walk through with 1, 2, 2. M is mean distinct element in AUS. Say 2. Say range subarrays. 2. Let me think with this. I expect this to return 3 because wait. Yeah, because since M is 2, yeah, 1 and 2 is valid and 2 and 2 isn't valid, so I will return 3. Okay. So here in line 51, this isn't true. Line 53 isn't true. So I go to line 53, 6, maximum is 0, and I will initiate the first range. So K, because K is 2, left and right is 1, 1, 0, 1. Num to count is different depth, quantum is 0. So here I will range 0 to 2. So I should be 0, 1. When I is 0, oh, wait a minute. Yeah, when I is 0, num to count 1 is 1. So num to count 1 is 1. Yeah. And in line 64, current sum is now 0 plus 1 is 1. And in line 65, because M is, yeah, I will check its oath. So range of num count is 1 and M is 2. So this is false. Wait a minute. So, oh, no, sorry. So before that, I have to iterate line 62 with I is 1. So here, num is 2. So num to count 2 to 1 is added and current sum is now 3. And then in line 65, I will check is also, and this is true because number of keys is 2. And I will update max sum is current sum, which is 3. Okay. And here in line 68, right is now 1. So 1 plus 1 is 2, which is smaller than rank sum 3. So this is true. So I go to line 69. So I pop out 1. And then the count is now 2. Yeah. So then in line 71, number count out is now so this becomes 0, and then this key is deleted. And it's in line 72. Current sum is minus 1 is deleted, so this becomes 2. Wait, number count out. Okay, yeah. And then left is now 1. Then right is added incremented by 1, and it becomes 2. So num's right is now 2. So n is 2. So num count is updated with 2 to 2. Yeah. Then current sum is now 4. Yeah. However, in line 80, its sum is now, because length num to count is now 1, which is not larger than 2. So this is false. It also is false. So max sum is updated. And finally, in line 83, I will return 3. Okay, good. This is as expected. So I will run this code. In line 53. Line 89. Let me check. Oh, sorry. I wanted to have. Oh, no. A is 3, which is the ranks of array. So 1, 2, 3. And it needs at least 2 different elements. No, sorry, I have to return the sum of them. Okay. Let me change it a bit. In this way, it should have at least 2 different elements. So 32, 32, 22 is the one. I should return 88. Okay. 'Let me add this case and confirm it also. Okay, so line 89 cases also failed. So my walking through was wrong somewhere. So let me check what is returned actually. 4 is returned. Okay, so it seems like max num is updated with 2 to range, maybe. Maybe this is. I see. Okay, here is the problem. So num to count out, it should be equal to 0. Okay. So the test part, so I will run this code in the LeetCode. Sorry. Good. Okay, yeah. I think this is a quite straightforward max sliding window problem. Yeah. So I finished this, yeah, practice. Thank you so much.